Today we're learning to solve one-step equations in algebra. Now, some of these you'll even be able to do in your head if you understand what the equation is saying. For instance, the first equation we're given is x plus 7 equals 4. So the question is, what number plus 7 equals 4? Now, some of you might have an idea what the answer is already, but I'm going to walk you through how to come up with the answer algebraically. And what we want to think of is we want to think of a scale running right through the equal sign with two sides balancing two different quantities. Now, right now, those sides are equal. That means the scale is perfectly in balance. But I want to figure out how much the x weighs. Now, in order to do that, I have to pull the 7 off from that side of the scale. But to keep it balanced, I also have to take 7 away from the other side of the scale. So whatever I do to one side of the equation, I have to do to the other side of the equation. When I do that, on the left-hand side, I'm left with just x because I've removed the 7. On the right-hand side, I get whatever 4 minus 7 is, which is -3. So that should be my answer. But if I'm not sure, I can check. Does -3 plus 7 equal 4? Yes. So -3, x equals -3 is our answer. So the whole key to solving equations today is to remember that whenever you do something to one side, you have to do it to the other one. For instance, in example 2, x minus 12 equals 3. I want to know the value of x. So how am I going to get rid of that minus 12? If I have a number, x, and I know that when I take away 12, I get 3, then x should be whatever I get when I add 12 back in. But if I do it to one side, I better do it to the other. So when I do that, I come up with x, just x on the left-hand side, and 15. So does 15 minus 12 equal 13? Nope, it equals 3, which is what it's supposed to equal. Alright, this works for multiplication and division as well. So if I'm given the equation -6x equals 48, right now, what's going on between that -6 and the x? Multiplication. And what undoes multiplication? Division. So let's divide both sides by -6. When we do that, we're left with just x on the left. And what's left on the right? What's 48 divided by -6? -8. Perfect. Let's just double check. Does -6 times -8 equal 48? Yes. How else can we approach these? What if we had x divided by 4 equals 5? How am I going to undo that dividing by 4? Right, multiply by 4. That leaves me with just x on the left. What's on the right? 20. Does 20 divided by 4 equal 5? Yes, so 20 is our answer. Now it gets a little trickier when we have fractions. Right now, I'm multiplying by -2/7. But I don't want -2/7 x, I want 1x. So I could either try to divide by -2/7, and that's a valid way, or what might be a little more straightforward is to multiply by its reciprocal, -7/2. -7/2 times 2/7 gives us just 1x. So now I've got to multiply 4 by -7/2. That gives me -28/2, which is -14. And you can check. Does -2/7 times -14 equal 4? Well, it gives me positive 28/7, which is 4. So we're good. -14 is our answer. Let's try a word problem. In the 2004 Olympics, Sean Crawford won the 200-meter dash. His winning time was 19.79 seconds. Find his average speed to the nearest tenth of a meter. of a meter per second. So we know that distance equals rate times time. And what distance did Sean Crawford travel? Well, it was the 200-meter dash, so he probably traveled 200 meters. Do we know his rate or his speed? Nope, that's what we're trying to find out. So let's leave that R there. Do we know his time? Yes, his time was 19.79 seconds. So to solve for R, since I've got R times 19.79 seconds, I want to divide by 19.79 seconds. And what do I get when I divide 200 by 19.79 seconds? Approximately 10.1 meters per second. There's my answer. I want you to try a few of these on your own. We'll pause the video, give you a chance to work over them, and then we'll go over them together. Try 5 over 6W equals 10. 9 equals negative 3 over 4M. And Q minus 11 equals negative 5. Give those three a try, and then we'll play through the solutions. Okay, so what we want to do is, with the first one, to get rid of that 5, 6, we're going to multiply both sides by the reciprocal. We get 60 over 5, which is 12. And make sure that you go back and check your answer. Does 5, 6 times 12 equal 10? It does. For the second one, again, we'll multiply by the reciprocal, negative 4 over 3. We're left with M equals negative 36 over 9, or over 3. And we know that equals negative 12. And we can check our answer. Does negative 3 over 4 times negative 12 equal 9? Yep. Last one. To get rid of that minus 11, we got to add 11 to both sides. And what's negative 5 plus 11? 6. Does 6 minus 11 equal negative 5? Definitely. So 6 is our answer. If you have any questions, feel free to ask. You can go back, watch the video again if you'd like, or if you're all set, you can start on your homework.